Hi guys, in the last video I have covered how to set the threshold for classification problems in machine learning using ROC curve. In this video, let's cover the remaining two methods using which how we can set the optimal threshold in a binary classification problem. The second method is precision recall curve. So what is precision? Precision is another metric which is true positive by true positive plus false positive, and recall is true positive by true positive plus false negative. So precision is like out of all the positives that the model has predicted, how many are actually right. That is precision. And recall is nothing but out of all the actual positives, how many the model is able to capture correctly. That is recall. So based on the threshold value, obviously the precision and recall also changes, right? So if the threshold is set to high value, very high, then false positives would be decreasing. Like in the example that we discussed, if we move the threshold towards right, then there won't be any greens after the threshold, right? So there won't be any false positives, right? So if the threshold is set to right, then false positive will reduce. So in the precision, since this value drops in the denominator, the precision value increases. At the same time, since the threshold is set to extreme right, then false negatives would increase. So because if we set it to extreme right, then all the red values that are to the left of the threshold, we assume it to be as negative, right? The model will predict them to be negative, but they are actually positive. That means they are false negatives. So their count would increase, right? So in that case, the false negative count would increase. So if false negative count increases, then here this value rises. So if the denominator increases, then the recall drops. So if the threshold is set to high, then precision rises, but the recall drops. Similarly, if we move the threshold towards left, so instead of setting it here towards right, if we move the threshold towards left, then the true positives would be more, but a lot of false positives would come because all the green circles, so if I set my threshold to be somewhere here, then all these greens are false positives, right? So all the values that are towards the right are the model will predict to be positive, but these are actually negative. So these are false positives. So the false positive rate would increase. So if false positive rate increases, this value increases and the precision drops. And at the same time, false negatives would drop. Why false negatives would drop? Because if we set the threshold to very low value, so the negatives predicted by the model is this side. So the model is not predicting anything to be negative. So for all these positives, these are correctly predicted as positives, right? All the red circles are correctly predicted as positive. So there is no false negatives. So then if false negative decreases here, then recall would increase. So by moving the threshold, precision and recall, one of them increases and the other falls, right? This is also called the precision recall trade-off. So when the precision rises, the recall drops, and when the recall rises, precision drops. If you want to choose an optimal threshold value, one way is choose another metric like F1 score, which balances both the precision and recall, and change the threshold and calculate the precision recall at every threshold value, and choose a threshold that maximizes the F1 score if, for example, both precision and recall are important for our use case. But first, there are some use cases in which precision and recall are not equally important. That means like the third one, use case specific. So what does this use case specific mean? It means like, for example, our machine learning model is trying to predict disease, diabetic or cancer. So in that case, false negatives are more important compared to false positives. Means the model should not classify any positive sample to be negative. because if there is a patient who is having the disease positive, but our model is predicting it as negative, the impact of it would be very huge, right? Then the patient would not be getting the required treatment and medication. So that's why in some particular cases false negatives are more important. That means this value is more important. This should be as low as possible. That means recall is more important in such cases. And there is another use case, spam detection, and we are using a binary classification model to detect whether a particular email is spam or not. In that particular case, even though if there is some spam mail and I am classifying it as not spam, right? In that case, false negatives are high. That means I have a spam, I am telling it's not a spam. That means I am telling it as negative even though it is positive. So that is false negatives are high. But if there is a non-spam and I call it as spam, that means it's false positive, right? So if there is some very important email that I have received and my spam detection machine learning model have classified it as spam even though it is not spam, in that case the false positives are high, then it would go to spam folder and I would miss out on that email, and if it is very important then I would be affected drastically, right? So in that case the false positive should be as low as possible even though false negative could be higher. So in that case precision is more important. So depending on the use case we need to choose whether we want to give more importance to precision or recall, and also it's up to us to decide what level of precision is good enough or what level of recall is good enough. Suppose if precision is more important and I cannot compromise on precision, that if I want the precision to be more than 0.9 at any cost, then in that case we need to set a threshold obviously that will give at least 0.9 precision. And so that if we set the precision to if we set the threshold to some value that gives a 0.9 precision, then recall would drop, but that's okay because we are not much concerned about recall. It's okay if we have false negatives in some cases. And at the same time, if you want recall to be like more than 0.8, if you want recall to be more than 0.8, in that case precision would drop. We will get some false positives, but that's okay, particularly in examples like disease prediction that we have discussed before. So it's important to have very less false negatives. In that case recall should be high, so I need to set my threshold such that my recall is at least this much even though my precision is compromised. So that is use case specific. So according to the use case we can choose threshold accordingly. Thank you.